comfortable with a neuron understanding, because in deep learning we'll be talking with lots of, we'll be actually dealing with neurons, neural networks.
Okay, we are okay with it. I mean, I'm okay with it. I don't know about others.
Ah,
Yeah, in fact, neuron is okay. Neuron perceptron is okay.
okay, perceptron is okay. So shall I go with very basic? I'm thinking of going with very basic, just to, for the first class today, and then I'll show you some kind of, Keras implementation. Okay, and actually I just probably 1 hour before I started, and my first epoch is still working, the model I was trying to build. And
Oh,
so anyways, I'll just show you that also, right? So let me spend 5 minutes on neural network, and then we'll just go ahead. I will not sort of, explain things very deeply about the model which I'll be showing you, which has been built in, Jupyter Notebook. But we will sort of uncover it one by one. It's sort of basis. Just wanted to show you that things can, work, and then probably in later classes will work. Okay, you can see my screen, right? So this is a perceptron, the simplest uh, neural network, right? Which is equivalent to your linear regression. There is an input and there is an output. Y is equal to mx plus c, right? Where x is x1, x2, x3, x4, right? So what happens is that uh, your input goes in, right? And then there is some wait happens. I mean, there is one sort of, forward propagation and then backward propagation, and weights get updated, and it sort of, it's the same thing which the Prasud was talking about, loss function, right? And the weight gets updated, and you get an sort of weights relationship is built, and then you go ahead and check the accuracy, etc. This is a simple neural network which is called perceptron. There is no hidden layers. So when there is no hidden layers, right, it can only talk about a linear relationship. The weights are going to be linear, right? But if you sort of, want to capture more complex relationships, then you start building layers between input and output. Okay. All right.
yes, yes.
Any question till now? So these
Mhm.
inputs here are your independent variables, x1, x2, x3, x4, and this is your y hat. I'm sort of, using all the terminology which Prasoon has already introduced, right? And here, from here, y minus y hat, you will see your error terms, right? And it will work on this, and will go back and forth, right? Going one full forward and then going one full backward is called one epoch. Okay, remember these terms. And guys, if I'm sort of, making a mistake, people who know deep learning or neural networks, please correct me. Soon, Ishwar.
Can you please repeat that?
Epoch is once you go one, you do one forward propagation and then one backward propagation to update the weights. And if it is, if you're finding it difficult, I'll make a note and probably, explain it with some example, with some sort of, numerical example next time.
You're already working on a deep like a neural network, right? In
I'm
your machine.
working. Come
You're,
again?
in your machine, you're training one model right now, right?
Right now, yes, yes.
Yeah. So after this session, you can show a brief about that model. You might have a verbose on, right? If the verbose is on, you can show us the epochs there.
हाँ epochs I'll show.
Okay.
All right. So this is one. Right. What is happening here is the formula, right? Same formula which Prasoon has also shown, which is your this is your constant bj, and this is your weights getting updated, and xi's are your input variables or the independent feature, right? This goes into your hidden neuron, right? There there are hmm, what are the functions called which are here? What are the name of those functions?
Activation functions.
Activation functions, and those activation function will output something which is called jz, right?
I have a doubt here.
Ha. Ha.
This Wij,
Hmm.
why is it indexed like that? I mean, Wi comma J.
J is your row sample,
Ye-
sample 1, sample 2, sample 3.
Yes, and we are iterating over the four inputs, like the four features we are taking.
Yes, yes.
Okay, so why Wij? I mean, can I see that neurons again, if possible? Yes. So if this input layer has four neurons,
Ha.
every neuron will get sample. Every sample will have four features. So it should be like Wixi, right?
Hmm. Hmm.
Why?
No, no, no. Wixi. Okay, yes. For every sample, yes. Wixi. Yes.
Yeah. So
Yes.
how come the J is introduced in the weight? I mean, is it being changed for another sample? I mean, is it one complete for feed forward and back propagation in one iteration itself, or does it?
If I may comment upon it, like if you see, just try to remember what Professor Monali has taught now, wherein how do we read this Wij? Uh,
Uh-huh.
J is the from, and sorry, I is from and J is to.
Okay.
Means like for the first layer, it is Wi is the only thing. But for the second layer, what happens? This is it becomes from like input one going to
Oh,
the third, and input one is
okay.
going to two also. Input one is going to one also.
Oh, yes, 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 yes. I
So
got remember right now. Yes.
so all these weights will be differing.
The
Like
edges. These are the edges, the connecting edges. Okay.
yes,
Yes.
yes.
Okay. Yes.
So my bad. These are not sample. These are connecting edges. So
Yeah.
everyone will have three of
Yeah.
them, right?
Hmm.
Depending on the number of nodes in the hidden layer.
Yes, of course. Yes.
J will vary from 1 to 3.
Correct.
Okay. Shall I move ahead?
Yes, yes, of course. Please.
And why we use in activation function like sigmoid, etc. It is to reduce the effect of extreme input values, right? To make network robust to outliers, right? Another important uh, point is to have a decay parameter to restrict the weights, to make sure that they do not become too large. Okay.
So it is a constant, like a hyperparameter.
Yes, decay is hyperparameter.
and it stays constant, just like the regularization parameter or say the learning parameter. The decay is stay, it will stay the same, point 0.1.
Is often said to, yes, yes.
Okay. Okay.
Okay. And as we I mean the first weight, right? Prasoon, when you started with the weights, you also start with a random number, right?
Yes, they do start with a random number very close to
Ah.
zero.
Ha ha ha. So similarly here, the weights start with excuse me, start with a random number, right? And because they are random, so you would want it to sort of average out over a longer time, and those are epochs, right? You would want to have once, twice, thrice, or 10 times or 20 times, depending on your understanding of the problem. And these are epochs, and that's why you would want different epochs, many numbers of epochs, and at the end you will average them.
Average, what? Average the weights.
Yes.
So, like, or if there is any weight which is learned by mistake or maybe in the initial phases, that also is taken into that average, I believe.
Yes, yes.
Okay. Okay. And
you,
is
you
this
do
generic topic,
what?
right? I mean, this neural network is a generic one. This is not related to the Keras or PyTorch
No,
or this
general,
is
general. Yes,
general. Okay. It's okay.
yes, yes. Right, and you know that we are using decay parameter, etc., to make sure that weights are not blown, right, too much, too large. Okay.
Yeah.
Okay. And how number of hidden layers, the more the number of hidden layers, the more sort of a complex relationship it learns, right? And number of nodes also, if you increase them again, you will have probably more uh, sort of complex relationship. But there is of course cost, computational power cost with all these choices. And what you do is you generally do a cross validation, right? You sort of excuse me, you take sample of data and make sure that you learn with these choices, with these choices of nodes and hidden layers, and then you decide on one, right? uh, yeah, that we do by cross validation, and we'll talk about it later. Okay.
Okay, but I can I ask you one thing? I mean,
Yes.
if you have gone through it, um, see these hidden layers. I was reading. I mean, I just read it superficially over this neural network for the exam as well. But everywhere I see that increasing the hidden nodes will increase the complexity of the model. It will learn of the intrinsic details of the data. But how does a node train asked in a model to learn over some specific detail? Is it there in a code somewhere that we specify, okay, so there are 16 nodes, one node will look into all these features, the second node will look into all these features? Have Is there a way to train them individually or instruct them individually, or is it just happens by chance? Like, I know it does happen by chance, but is there any way we can justify this understanding?
uh
Like,
Justify.
you're training your model right now, correct?
Right, right.
You might have a dense network, some hidden layers for say 4, 5, 6, whichever
uh-huh.
supports your machine, right?
Uh-huh.
So you must have asked activation layer to every hidden layer. So when you're asking, okay, go with Relu or go with Sigmoid or Softmax, so you must be thinking now that this particular input, when I'm taking this data set, this might be like probabilistic data will come through it and I will have to take some higher probability. So have you programmed it by any hyperparameter, say say this dk parameter or maybe some other hyperparameters, did you specifically instruct those hidden layers to work out on some features?
Actually, Prasoon, what you are saying is interesting because my understanding is that the more sort of nodes you will have, there will be much more granularity,
Of course, yes.
right? So this
Uh,
is my understanding of nodes,
but which
and
granule to take, that is not really, I cannot see that really. I mean, like, I cannot even visualize, imagine it.
yeah, I mean, imagine the sense. See, there is a sense of randomness, of course, no doubt about it, and it remains. We can only think of, we can think of how it is going forward, how it is going backward, but like you said, individual node you cannot program,
Okay,
right? So
okay,
so the only kind of understanding which comes through it is to sort of, because they are different, we have sort of different nodes, and every single input is going to all the nodes,
yes.
right? So there is
Hmm.
some different information which is being captured by every single node.
Yeah, of course. Then FCNN will be having every features will be there with every node, and CNN will have some other features, some will have not. Like that
Yes.
kind of connectivity will help in future maybe.
So intuitively I can understand it, but yes, I mean it remains, I can understand, I can do some kind of maths around it and see what will be the value, what are the values which are coming out of it, and after it looks at the loss function when it does back propagation, what the maths about it. But my
Mm,
intuition is this, that more the nodes, more sort of granular it will become, more the layers, more complicated it becomes.
of
So
course, yes. Complication,
granularity.
that is for sure.
uh,
Complexity comes, that is guaranteed. But so far, I
Complexity comes by increasing the hidden layer, and granularity comes by increasing the nodes.
okay, okay.
That's what my thought process right now is.
Okay. Okay, I'll remember that. Maybe this will help in any other resource which I'll come across.
Yes, we can test that whether but there is always a sort of how to put it. There is a trade-off between
Yeah,
these things, as we know about yeah,
yeah.
computational power, and after a point of time, uh, you really wouldn't want to increase it.
Of course. Mm.
So this is it. So I'll just, what I'll do is, I'll just show you the model. I will not talk about the codes. I'll just give a general understanding. One, because I myself am not very sort of I don't know exactly everything about it. And second thing is probably we are also pushing off
Just go for the
time.
step. That should do for now. Just going out through the steps, no, that will help.
Uh,
Give the basic idea of what to start, when to start.
you can see my screen,
Yes.
right? So install your TensorFlow and Keras, right? And this is cat and dogs data set.
Dude,
Okay.
this is your own, but this is your own machine.
Ah,
You can run Keras on your own machine. I mean, how come
I
my system just freezes and the kernel shuts down? I don't
yes,
know
yes.
why.
Pretty slow. I mean, this is 16 GB RAM. So
Okay, okay.
office laptop actually. Even actually, I have a GPU in my personal laptop. I could have used that actually. It is taking lot of time.
Is
I
it
bought that.
NVIDIA? Otherwise, it won't work because AMD Radeon doesn't work. I came to know.
Come again. Come again.
If you have a NVIDIA GPU, you
Yes,
can
yes.
use it for training. Radeon is not really helpful.
I have NVIDIA one.
That is good. That uses CUDA, no? CUDA.
Yes.
That we use.
I'm not
Okay.
technologically that advanced, but I bought that only 2 3 years back only to understand more about deep learning. But yes, anyways.
Okay.
So this is a data set which has I'll just show you the yeah, but 1 second, shall I show you the data set so it will increase your familiarity. Let me show you.
Screen.
Now you'll be able to see my screen also. Okay, yeah. Right, so it's real. So they in this data set there are cats and dogs images.
Mm-hmm.
Okay, we have a lot of these images, cats and dogs.
11,000. Okay.
Yes. Okay, and same dogs images. Okay,
Okay.
and the model we are building is uh, of course which sort of tells us whether a particular image is of cat or dog. Okay,
Okay. Okay.
and so the first step is to get these images in, right? Create a
Okay.
data set,
Okay.
right? And batch size is your, you know, in one epoch,
Mm-hmm.
how many batch size is your sample size. We have
Okay.
11 thousands and all those things, right? Remember these things: batch size and your epoch size. Epoch size is your how many times you are going, doing one iteration complete
Okay. Okay.
training. And batch size is the sample which you number of images you are choosing for in one epoch.
Okay.
Okay.
Got it. Like it is like cross validation. We take some part of the data
Yeah,
for
20%
one.
of it. Yes, yes, yes. 10,
Oh,
or if we are doing 10-fold validation or 5-fold validation. Would
okay. Okay. Got it. Got it. Got it. So
yeah,
how
10.
many? What is the epochs like you are using? Have you? Oh, you will
Yeah,
mention it later.
training. It's actually I just put three. I started with 25, and it is like for 1 hour it has completed one epoch, right?
Okay.
So we don't know how much time it's gonna take. So it's on second epoch. I've just given it three epoch for now.
Okay. And one batch size is 125 or so.
128.
128. 128 images it will take for one epoch.
Yes, yes.
Okay. Understood.
All right. So what we do is we split it in the regular machine learning stuff. We'll split it between 80% of training and 20% of uh,
Validation.
validation. Okay,
Acha,
and
one,
then
I was meaning to ask you this.
uh,
When I was looking into the neural net
mm,
from MIT and these other lecturers,
uh,
they told that when we go for this neural network, especially for image processing,
uh,
what they used to do is they would take a square image and then they will make it in tall, skinny vector.
this is
Like,
augment. Acha, tall skinny vector. Okay, okay.
yeah, so we are not doing this in reality, right? We like you have used 180 by 180 pixel of image size only.
Yes, so this is also a way of doing it, right? That is also uh, that is also one step, one way of doing it, and people have done it with MNIST data set and all, right? But I
Yes.
think Keras is a bit different. It takes much more sort of kind of holistic way of sort of forecasting,
Okay.
right? Or sort of segmenting. That is pretty original way of doing it, right? Vectorization in which every pixel you give it 0 or 1, whether a certain pixel
Mm-hmm.
is populated or not, in
Mm.
RGB scale.
Yes.
Yes.
Okay.
So
Here,
uh,
one epoch equal to how much? How epoch is calculated?
epoch is epoch is one sort of a complete forward and backward propagation in which weight gets updated.
One complete cycle you are talking about then.
Yes, one complete cycle is one epoch. So we take some sample of these images. These are these images, right? These are images, and you also do some data augmentation, right, to improve sort of you flip them around, make
Oh,
them bloated and all those things,
okay, okay, okay.
right?
Yesterday it was told, no? Drop documentation. Yes.
So
Okay.
this is like, for example, this is getting augmented. This you create a
Scripted, scaled, rotated. Yes.
yes, yes. Scaling is done next, right? In which what is happening is that you will sort of instead of 255 of your RGB scales, it will be between 0 and 1.
Yeah, I'm already scared. Yeah, have you written all these line of codes by like yourself?
No, no, no. This is in Keras. This is
It
in
is given
Keras.
in class.
Yeah, yeah. All these are given.
Okay,
Okay.
okay, okay,
I'll share the link also.
okay.
Right. And after this, I don't know much about these, parameter values, but just to show you that how things are done.
Mm-hmm.
And probably by the next time we all will sort of combinedly will study it and share resources to understand them better. So after that you start creating model, right? And you when you create your model, you sort of give your activation function. You will decide on what is the neural network, type of neural network which you'll be using, which is here convoluted 2D, right?
Mm-hmm. Mm-hmm.
And all these parameters you will assign and create your model. Okay.
Yeah.
And then there is a dropout which you want to keep aside, some sample. And after
So
that, yeah,
the dropout is point 0.5 of
yes.
the total layers, global average cooling.
Probably
I
these are left behind. Yes, I will
so
probably yeah.
this
Anyone has the idea of dropout?
no, I was
Anyone?
supposed to give that session also, but I have not yet completed neural network, so I'm not sure I'll be able to make it. But what is the global
So
average?
yesterday, yesterday,
Yesterday what?
yesterday we have learned about dropout. That's a regularization technique, where in
Okay.
which if you put zero point 0.5, randomly 50% of the node will get removed, and then the epoch will continues, and the next iteration another set of 50% of the nodes will be removed, and then whatever removed in the earlier epoch will be activated. It's just a kind of technique for regularization to provide more training data,
Okay.
like
Yesterday.
granular data. Yeah,
Okay. Who explained it yesterday?
I think it's me. I only explained that. Yeah, it's a
Okay.
dropout layer altogether. It's a regularization layer we are adding here
Uh,
in
okay.
between
Okay.
activation and
Satish. Okay, Satish. Okay. Okay.
yeah, yeah,
I okay. Probably I should attend more of everyone's session to sort of, so there is a cross sort of learning happening, right? Yes.
yeah. That's right.
Thank Okay. So great. So also Manoj, let me know. I am also interested in those questions and all, right? We should start solving. I mean, we should be completely geared toward, the of course learning, but also towards these questions. So how do I access them? In, how do I access them in the questions and solutions? You just let me know. Yes, and whatever the discussion which has happened on them, solution kind of thing also. Okay. So that question, sort of solution we have prepared for that question. Okay, okay. Document is created out of it, right? Ha, I want that. Okay, okay. And in the last cell, you can see that the model is being run, but you can see here that accuracy is pretty low here, right? And it is still running. Probably it will take 1 more hour to run, to complete all the three epochs. But we can see from the end, from the end where the Kera website is. Ultimately, what will happen is when you will have after this gets completed, after the complete training of the model happens, all the epochs have been run. You have your model, then model.predict any image when you take up, right? And
Mhm.
then when you pass it along to the model, this will say, you will get this message: this image is 85.28% cat and 14.72% dog.
Hey, this one uses the this image to array. Maybe this is using that tall skinny method.
Vectors, converting it to vectors, is it?
Yes.
Yes, yes, yes.
Ultimately, I think that should happen anyway, right? Because yeah, some vectorization has to happen, isn't it?
Yes, of course.
Even if it is 180 into 180, every cell of that 180 into 180 will have some information.
Yes.
So when we are thinking about nodes, probably say top left 2 3 gets goes
Redundant.
to one node, and bottom left 2 3 cells go to one node, right?
Yes,
That is the kind of granularity probably nodes will get in.
of course. Yes.
So
What
that
are
is
these boxes which are made? These
this is
tables?
yeah, this is graph visualization, right? And this is the
Uh, okay.
first input, and this input layer is 180 180. I think that third one cell or something like that. I don't exactly know.
Okay. So all these steps which it is taking output of.
3 is the RGB. Okay.
Yes.
Three,
When they were solving on the yes, yes, yes. The
so
running time.
red, green, blue. So 3 would mean what?
Three, one for red, one for green, and the one for blue. So total three times you will have
Ah,
to.
okay, got it. So red, green, and blue. So less of blue, more of red and green. Okay.
No, not like that.
Or
One filter will take out all the red colors.
uh,
So 180 by 180 pixel of red filter, then 180 by 180 pixel of green filter, then 180 by 180 pixel of blue filter. So total, how many will you find? 180 into 180 into 3. Total number of pixels you will be
oh,
working with.
okay, got it.
Yeah, even
Okay,
I
there are three
forgot. You just
filters. Three filters. Got it. I just wanted to show you. I mean, I myself don't know much about it. I know the basic intuition,
Mhm.
but I have not done much sort of productionalizing deep learning.
These
Okay.
are all these codes are overwhelming to see. Already scared to how we will write all this in the assignments.
This flow, can you repeat? Can you explain this? Yeah, this flow diagram. What exactly how it is?
Satish, do you
It is
Satish?
they.
Yeah.
Uh, yes, Vinay.
Yes. Do you want to go ahead? Someone asked a question, right? Who asked the
Yeah,
question?
So
this
they,
flow.
so they
Can you explain actually the tree diagram? This
Ah.
flow.
Okay, so each and every diagram is having, representing different layers. The first one is input layer.
Uh-huh.
Right? So we already learned it. Like, so we, I mean, pixels. Uh, o- like 180 into 180 and 3. That's the input layer. And then from the input layer, there will be output. Again, it's same. It's going to the next
180
layer.
into 180 is the size of every picture, right?
No, what is that?
The input.
First argument is none, then another argument 180, 183. Can you tell me first argument none means what?
It's the given images pixel size is 180 into 180. You know, right? So if you consider that, there'll be a matrix 180 graphs 180 to
That is the
represent
pixel
that
size. Then
image.
third parameter
Pixel size.
3 means
3 is it's a colored image. So if it's a black and white, it's going to be 1. Since it's a colored image, whatever Vinay showed, right? The dog and cats, those images are colored image. So to represent that, we need to have RGB values. Okay.
what is none? Why none means?
I think none is like the first parameter. I don't think maybe we can.
And your explanation is there for how this tree is for growing.
So here you could see.
Yeah, you know.
None is constant everywhere. So probably that is one way of sort of uh, putting in the vector, because none is everywhere. See,
And
none
why
is
it is
everywhere.
everywhere none is kept, how it is impacting to calculate for other? Is there anything? How, why none? What is that parameter indicates?
Maybe bias is what I'm thinking.
Okay.
Here, any explanation is there for the code?
Yeah, that's why. Can you please scroll up, Vinay, bit the code part? So, still the input layer, the very first one. Yeah, hold on. So in make model, what is the first parameter they're passing?
Input and number of class.
Maybe the notebook will be useful. Okay. Okay. Where are we calling that make model?
Make more use. This is our model. Model is being called here, no? Model here is
Make
make
model.
model.
Okay. Okay. Number of classes two. Okay. What is image size here? 180 into 180, is it?
Yes, image size is 180 into 180.
The variable, whatever we.
Yes, it's 180, 180, comma 180.
Okay. I think it's more or like specific to Keras. I like it's not. Maybe we can dig deeper and then we can.
Yes.
But it looks to me that it's gonna be a bias. I think.
Cool. I think it's good to know. Actually, it's my first time when I